Hello, good morning, good evening, or good afternoon. My name is Avnish, and I am with Azure MySQL Engineering. Thanks for taking the time to join this session in your busy schedule. In this session, we will discuss different migration technologies you can leverage to migrate your MySQL instances to Azure. I hope the information we share will be helpful in your future migrations. But before we discuss the different migration options, let's review the triggers we are seeing in the organizations who are making decisions to migrate to cloud. In the migration triggers, when a data center contract expires, usually an organization expedites the migration to the cloud. Another trigger we have seen is the pressure to reduce capital expenses. Every time you buy new hardware or software, these are expenses. And moving to the cloud helps you reduce your capital expenditures. And obviously, security and budget constraints are other driving factors in migrating to the cloud. With the pandemic, many organizations are forced to enable hybrid work as well. And finally, faster time to market, application innovation, cost optimization are other triggers driving organizations to the cloud. Azure Database for MySQL is fully managed OSS Community Edition of MySQL. Um, you can take advantage of end-to-end business continuity and more robust security options because of the integration we have with different partner solutions as well as Azure security solutions. You can scale up, scale down to meet your application requirements, and you will see different options to optimize your cost and reduce total cost of ownership. As budgets are constrained and we are all asked to do more with less, the best way for an organization to free up resources to focus on more impactful business activities is by leaving all the admin work to us or to the cloud providers. With MySQL Pass, Microsoft handles everything from data center management and hardware maintenance to running applications with high availability. Having Microsoft handles everything except for your application and data means that your organization can be more flexible with budgeting and handling unforeseen events like COVID-19. And not only does Azure DB for MySQL take the admin work out of your MySQL workloads, but it also improves your ROI by giving you access to the integration with a wide variety of industry-leading Azure services like intelligent security and performance and others, which we will highlight later in our presentation. In Azure Database for MySQL, we have two different deployment options. Single server, which comes with built-in high availability, and it was GA'd 4 years ago. And over the last 4 years, we had hundreds of customers deployed new applications or migrating existing applications from Azure to from on-premise to Azure. And based on the customer feedback, we introduced flexible server in November, where you have maximum control for your database instances. In flexible server, when it comes to maximum control for your database instances, you have an option to have custom maintenance window, which you can use to control plan outage, which Microsoft does every month to do the maintenance on your database instances. With custom maintenance, you can pick an hour window any day of the week or any day of the month, and we will use that hour to do the maintenance. Further, if your application has multiple environments, production, development, staging, and so forth, you can use custom maintenance for your production instance and system schedule for your non-production instances. And we maintain 7 days gap between custom schedule and system schedule, which would allow you to ensure that there is no impact on your production application because of our maintenance. Now with network isolation, you can deploy a flexible server in VNet with VNet integration to ensure all your application traffic stays within your VNet. And finally, we are also exposing a lot of parameters which you can use to fine tune your database instance. With high availability, you have an option to do zone redundant deployment. We guarantee data loss regardless of whether it's a planned failover or unplanned failover. And finally, with zone aware database server, you can ensure that your application and database instances are deployed in the same zone to minimize the network latency. And finally, on the simplified developer experience, with guided developer experience, increase productivity and simplifies end-to-end development. And because we have full compatibility with community edition, you can continue to use the same tools you have been using in your on-premise environment. And finally, you have an option to stop and start database instances when you are not using these, and also burstable capabilities for cost optimization. In Azure Database for MySQL, you have an option to retain your backups up to 35 days. By default, it's 7 days and minimum is 1 day. So if you have non-production instances where you don't need to retain backup for longer retention period, you can retain only for a day or couple of days, and that will reduce your storage requirement to retain these backups, which will eventually reduce the total cost of ownership for these instances. And by default, all backups are encrypted using AES 256-bit encryption. Now in Azure Flexible Server, you have two options to do the high availability. One is single zone high availability. In this case, both primary and the standby instances would be in the same zone. It won't protect you against the zone failure, but it will give you much better performance because your primary and standby in the same zone. So there is no network latency between these two instances. Now other option is the zone redundant high availability, where your primary instance would be in zone 1 and standby instance would be in zone 2. So it will protect you against the zone failure. If primary zone goes down, we will automatically fail over to standby instance without any data loss. And if your application has the retry option, then it will automatically reconnect when instance comes back. Now, because of these different configuration, we offer different SLH, uptime SLH. If you provision flexible server without any HA, then we guarantee 3 nines or 99.9% uptime SLA. And if you configure same zone HA, then we guarantee 99.95% uptime SLA. And finally, if you do zone redundant high availability, then we guarantee 4 nines or 99.99% uptime SLA. Now, beyond keeping your business running smoothly, we have heard from our customers that security is one of the most important areas when considering a move to the cloud. You can rely on multi-layered hybrid security in Azure, be it customized hardware or security controls integrated into hardware and firmware components. Azure Database for MySQL supports the basic authentication mechanism for MySQL user connectivity, and data in MySQL instance is encrypted by default. Any automated backups are also encrypted, as we mentioned in the previous slide, to prevent potential leakage of data to unauthorized parties. And one of the biggest benefits of moving to Azure DB for MySQL is the ability to maximize security through integration with many Azure and partner security solutions, like Azure Active Directory. This security integration works by issuing tokens that act like passwords during the MySQL login process. And configuring Active Directory integration is incredibly simple and intuitive to do and support not only users but also Active Directory groups. Now, when you migrate your MySQL instances to Azure Database for MySQL, you have multiple options to reduce the cost or eventually total cost of ownership. One, as I mentioned, the option to stop the MySQL instances when they are not in use. And there are multiple use cases where it might make sense to stop the MySQL instances. One is the development or POC scenario. When you are not using those instances after business hours, you can shut down these instances and you would be paying only for the storage. There is no compute expenses during that time. You also have the option to use burstable CPU credits for workloads that require more capacity during peak times. And finally, with high availability, you have an option to eliminate tangible and intangible downtime cost, including revenue, productivity, and the brand name reputation. Now let's switch to the migration, and we will talk about different migration options you have for your MySQL instances. But before that, let's review this migration journey. Every migration has three phases: pre-migration, migration, and post-migration. During the pre-migration, you identify the MySQL instances which you need to migrate from on-premise or other cloud providers to Azure. You identify the applications using these MySQL instances, how much downtime each of these instances or applications can support. You do the compatibility assessment to make sure your on-premise MySQL instances are 100% compatible with Azure Database for MySQL. If you are using Community Edition in your on-premise environment, then there won't be any feature parity gaps. However, in Azure Database for MySQL, because it's a PaaS service, you won't have any super user permissions. So if you have any database objects owned by super user, then you have to switch those objects to regular database user. And finally, storage engine. In Azure Database for MySQL, we support only InnoDB storage engine. If you have database objects in different storage engines, then again you have to migrate those to InnoDB storage engine. And finally, migration. Because you are doing the homogeneous migration from MySQL to MySQL, your schema and data would be migrated in the same step. And you have, based on the application criticality, you have the option to do the offline migration, which you can do through dump and restore, or using Azure Database Migration Service, which is a managed service. And I will cover this further in our coming slides. But if you have an application which is very critical and you cannot tolerate much downtime, then you have an option to use native logical replication, which would allow you to migrate with near zero downtime. So only downtime you would require will be during the cutover. And during the migration, it's quite possible that you require more capacity, whether it's compute or IOPS, to make sure you don't have any bottleneck on the CPU or on the IOPS during the migration. But once you are done with the migration, then you can scale down your compute to make sure it's sized properly to meet your day-to-day performance SLAs. Now in Azure Database for MySQL, you have two options to do the offline migration. MySQL dump, which is a single threaded, and its native MySQL utility. When you install MySQL, you will see MySQL dump utility. It's a very good option because it's easy, but it's good only for the small database instances. Because of the single threaded, if you have large database MySQL instance, let's say over 250 GB, then it can take several hours, which may not be the right option for the migration. Now, second option is the MyDumper and MyLoader. It's a multi-threaded utility. It requires separate installation. So if you plan to use it, you have to install it separately and then use this to dump the database, and then MyLoader would be to restore. And based on the number of cores you have on the machine where you running these operations, you can specify number of threads you want to use for your dump and restore. And if you cannot tolerate much downtime, as I mentioned, you can use data and replication. So you will use MyDumper or MyDumper and Loader to do the initial seeding, and then set up the data and replication between your on-premise MySQL instance and Azure Database for MySQL to keep target in sync until you do the cutover. And finally, we have Azure Database Migration Service, which is a fully managed migration service to simplify, guide, and automate your database migration to Azure. And Azure Database for MySQL, you have an option to use Portal, which is a GUI experience, but we also provide PowerShell or CLI commands, which you can use to automate your migration if you have multiple instances you plan to migrate. And in Azure Database for MySQL, we support Microsoft SQL Server, MySQL, Postgres, and MongoDB migration to Azure. It's highly resilient and self-healing migration service to provide reliable outcomes with near zero downtime. Now, because we have two different deployment options, single server and flexible server, and flexible server went GA November last year, we recommend customers to migrate to flexible server. But for any regions, if you need to migrate to single server, these are some of the parameters we are recommending to fine tune before you do the migration. I won't go through these parameters line by line, but one of the parameter I want to highlight here is scale up storage tier. In single server, IOPS depends on the storage you allocated in your single server instance, and it's 3 GB per 3 IOPS per GB storage allocation. So you may have to allocate more storage to make sure IOPS are not the bottleneck when you do the migration. Now, when you do the offline migration using MySQL dump or MyDumper/MyLoader, as I mentioned, If you're doing migration using mydump or myloader, you can specify number of threads, and another parameter is rows equal to 1000 in this case. So if you have a large table which you are migrating, then you can specify this parameter. And based on the value of this rows parameter, mydumper myloader will split that table into small chunks of 1000 rows in this case. So mydumper myloader not only allow you to parallelize your entire backup and restore operation, it also allow you to parallelize your large table migration and restore of those tables. And finally, you can specify this parameter transaction consistency only. It allows you to have a consistent backups while your application is up and running. So you can continue to make DML, DDL transactions while you are doing the backup of this database instance. Now for the near zero downtime migration, you will still require to use MySQL dump or mydumper myloader to do the initial seeding. And once you have the initial seeding in place, then you can use procedure AG replication change master to switch the master. You specify your MySQL instance in Azure, username and password. Port by default is 3306. And if you're doing binlog replication, you specify the binlog file and the binlog position. And if you're using SSL encryption, then you specify those keys. But if you're doing GTID based replication, then all you have to specify is the host name, username, password, port number, and the SSL key. And once you have the change master in place, then you can start the replication. And finally, during the cutover, you stop the replication, and that will basically complete the migration of your on-premise MySQL instance. Then you switch your application connection string, do the application testing to make sure everything is functioning fine, and then finally you go live. As I mentioned, another option is the Azure Database Migration Service, which is a fully managed service to provide you seamless migration experience to Azure. We support currently offline migration of your MySQL instances, but sometime in August or September, we will have the preview feature which would allow you to do the binlog replication after the initial seeding using DMS. So you can do both initial migration, initial seeding, as well as replication to support the near zero downtime migration. And with DMS, you can also migrate all the tables, views, triggers, events, and routines, and then finally set up the replication. And a couple of months ago, we also introduced this new feature called consistent backup. It allows you to back up your MySQL instance on premise without any outage. So with consistent reads, if queried data has been changed by another transaction, the original data is reconstructed based on the contents of the undo log, which holds copies of data modified by active transactions. If another transaction needs to see the original data, the unmodified data is retrieved from the undo logs. And main threads gets a read log on the server to ensure all connections start from the same point in time. We will do flush table with read log. And if you're doing the migration from RDS, then it's a different command, log tables table name. But these are all the transactions or the logs we apply behind the scene based on the source, whether it's coming from on-premise or from RDS. And then we spawn all connections required for the migration with consistent snapshots. And finally, you will have the bin log position to start the migration. And once migration is completed, we close all the open transactions. Now, as I mentioned that we have single server which was GA'd almost 4 years ago. And over the last 4 years, we had thousands of customers who deployed new applications or migrated existing ones to single server. To provide a seamless experience from single server to flexible server migration, we will have a new service which you can leverage to not only do the assessment of your single server to make sure it is 100% compatible with flexible server. We will also migrate schema users and data. Further, we will also migrate all the parameters you might have fine-tuned or the firewall rules from single server to flexible server. And if you have any read replica in your single server instance, we will provision new read replicas in flexible server as well. So it will give you seamless migration from single to flexible server without changing the connection string or without any outage. But you would have the option to do both offline or online migration. And finally, you would have the both portal experience and CLI experience. So if you are planning to migrate large number of MySQL instances from single to flexible server, you can leverage CLI to automate this migration experience. Now let's look into the demo on how to migrate your single server instances to flexible server. So in this demo, we will do the migration from single server to flexible server. So this is my resource group. And here I have the Azure Database migration service, which I provisioned in a VNet. Then I have a project I created within the DMS. This is my virtual network. This is my flexible server, which is my target instance. And this is my single server, which is the source instance I'm going to migrate to flexible server. So let's look at the single server first. So here I have, so this is the overview page. As you can see, this is my server name. This is the admin username. And I'm running MySQL 5.7. And it's a general purpose 4V core 100 GB storage allocation. It's provisioned in South Central US. And when it comes to connection security, so because it has the public endpoint, and these are the IP addresses allowed to this instance. You can also see the connection strings, which different programming frameworks can use. And you can also see in the pricing tier that I'm using 4V core and storage is 100 GB allocation. If you need to scale up, you can simply slide the bar to allocate more V cores, and same is true for the storage allocation. On the properties, you can see the server admin name. You can see the resource group, subscription ID, subscription name, and so let's go back to the flexible server. So this is my flexible server. Again, in the overview page, you can see the server name, you can see the admin login name, you can see the server configuration. So again, it's 4V core, and I allocated 512 GB storage, and it has 16 GB RAM. MySQL version is 5.7, so same as single server instance. Both are provisioned in the South Central. And in the compute plus storage, you can see the similar information. So in flexible server, we support three compute tiers: stable, general purpose, and business critical, which can scale up to 80,000 IOPS and storage allocation of up to 100 terabyte. You can, if you need to switch to different compute tier, you can select those here. And storage allocation is simply matter of scale up, sliding the bar. In the networking, you can see that I'm using private access. So this instance is deployed in the VNet. It's in the same VNet as my DMS instance. So I don't need any additional networking configuration because both flexible server instance and Azure Database migration service are deployed in the same VNet. Different subnets though, because flexible server requires dedicated subnet. And DMS currently requires all the source databases exist in the flexible server. So in this case, because we are doing the migration from single server, and there we have two databases, Album and Scratch. So I already created those databases in the flexible server, and these are empty databases. In the connect, you can see the host name, username, password, SSL. So these are the connection details which you can use to connect to this flexible server instance. And then we have server parameters where you can see different server parameters values. You can change them. So if it's a dynamic parameter, you can change it online. If it's static, that will require rebounds of the, you have to bounce the flexible server instance. In the replication, you can create read replicas, which you can use to to support your DR requirements or to offload the read-only workload. And then maintenance, as I mentioned previously, in flexible server we support system managed schedule and custom schedule. In the custom schedule, you can select day of the week, and we have a day of the month coming soon as well. And you can start the time. You can specify the start time. So for example, this one is 1 a.m. to 2 a.m. UTC time, and maintenance is scheduled on Sunday. So we will use this window to do the maintenance. And you can specify this maintenance schedule for each instance separately. And then you have the high availability. So in the high availability, if you provision flexible server with HA, then you can enable or disable HA anytime later on. And depending on the region where you deploy, you would have the option to enable same zone HA or zone redundant HA. And in this case, because it's the same zone, but if you have zone redundant high availability, then you can select the zone where you want to have your standby instance. So again, if you recall, with this zone configuration, it gives you complete flexibility to ensure that your application and database instance are deployed in the same zone. On the backup side, you can see all the full backups we had so far on this flexible server instance. You can use these backups to do the fast restore, or if you need to do the point in time restore, you can come here in the overview page and click on the restore and specify the restore point in time, and then it will restore to this point. And then we have the advisor recommendations on the performance tuning. So I don't have anything, but you typically can see here what are the different indexes you should add to improve the performance, or if there are indexes which you should drop to improve the performance. You will see these recommendations here. In the metrics, we are exposing several metrics which you can use to monitor the health of your database instance. And similar metrics are available on the single server as well. So as you can see the replication lag in seconds. You can see backup storage used, CPU credits consumed. All these metrics are available in portal as well as in the CLI, and you can use these metrics to generate different alerts. So, for example, if you want to generate an alert when your CPU is 90 minutes for last 5 minutes, you can configure these alerts. So let's come back to the database migration service. So this is the database migration service I provisioned, and this is the project I created. So in this project, I don't have any activity. So let's create an activity. Well, so in the project, we have no activity. So let's create an activity to migrate single server instance to flexible server. So it's an offline migration today, but sometime in August or September, we would have a preview feature which you can use to migrate with near zero downtime. So this is my single server instance. By default, this is the port number, and this is the username. And so this is the feature we discussed in the slides previously. This is the new preview feature, enable transactional consistency. So it allows you to do the migration while your database instance is still in use. If you want to do complete offline migration, then you can make database in the read-only mode. So let's select the target. So it's trying to establish the connection with the single server instance, and soon we will see the window for the. So now we provide the information on the target server. So you specify the subscription, you specify the region where your flexible server instance is provisioned, the resource group, and the target instance. And then you select the database you want to do the migration. You can also specify whether you want to migrate all the views, triggers, events, or routines. So let's select all of them, because in this flexible server instance, I just provision the empty database. So as you can see, if your target database name is same as source database name, it will automatically do the matching. But if for any reason your target database instances are different, then you have to select the target database you want to migrate to. After selecting the database, then you specify the tables you want to migrate. So by default, no tables are selected. So we're gonna select all the tables. So for each database, we selected all the tables and then configure the migration settings. So if you want to do advanced migration setting, there are certain settings we are exposing, which you can use to configure advanced migration settings. So for example, desired range count, write batch size in kilobytes. You can specify all these different settings if you want to fine tune your migration experience. So let's leave those to default and specify the migration name and start the migration. So as you can see, the migration is just started. The album database is 2.95 GB and Scratch database is literally 15.15 max, so very small. Altogether, we are doing roughly 3 GB migration. So if you click on the album database, you can see the status of each table migration. So album table is already migrated and item table is migrating. It's in the progress. And so far 35 million rows are migrated successfully. The item table migrated successfully, which had roughly 400,000 rows. So it took only 13 seconds. So item table is still going on. As you can see, some of the tables are quite large, but this product table is also completed, which had roughly 10 million rows, and it took 37 seconds. So let's look at the other database. So Scratch database is completed. So obviously many of the tables here are empty, but it took altogether roughly literally 3 seconds. And if we come back to album, so 3 tables are still running. But while we are waiting for this to complete, so what I demoed here is the migration of single server instance to flexible server using the Azure portal. If you want to automate this, you can use set of CLI commands, and that would allow you to migrate multiple instances using the automation you're going to build. So looks like migration of all the tables completed. So the largest table I had was this supplier table, which had 22 million rows, and it took roughly 5 minutes 51 seconds. Altogether, it took close to 11 or roughly 12-13 minutes to migrate 3 GB database between these two databases. So with that, I will wrap up my demo, and I hope you find this information helpful. If you have any questions, please let us know. Thank you again. Really appreciate the time you took to listen this session. Bye.